Okay, so just continue the previous class, numerical, whatever we discussed, that means per unit quantity of the low voltage side and high voltage side are equal. We already seen in the previous class, either maybe resistance, leakage reactance, and impedance. Okay, so just we try to see some problem based on that. So, just share the screen, then leave it here. So we already seen that the resistance, reactance, and impedance, either the low voltage side and high voltage side, are equal. Okay. So in the next, we will just consider one example. That means suppose that we consider a 20 kVA 2500 divided by 250 volt single phase transformer has leakage impedance of ZEH. That means equivalent leakage impedance on the high voltage side is equal to 2.6 plus J4.3 in ohm when referred to HV side. Okay, that means this impedance given when all the parameters are referred to the HV side. HV side, that means a high voltage side. Find the per unit value of ZEH referred to the high voltage side and low voltage side. Okay, so just you try to read this problem once more here and try to observe that what you require to find out here. Okay, that means J equivalent leakage impedance on the high voltage side given in per unit. Okay, given in per unit, and you require to find out the equivalent leakage impedance on the high voltage side, refer to the high voltage side and refer to the low voltage side. Okay. So first of all, you know, we already seen in the previous class that how we can transfer the impedance from one side to another side. Okay. How we can transfer the impedance from one side to another side. Okay, so concern about your low voltage side and high voltage side. If we first of all solve for the high voltage side, that means already given the problem impedance in high voltage side. Okay, and if you consider that in part A and part B, okay, that is find the per unit value of JDH referred to the, this one may be considered as part A and this one may be considered as part B. That means high voltage side, HV represent for high voltage side and LV represent your low voltage side. Is it not? HV represent for high voltage and this one represent for the low voltage side. So first of all, we just consider about the high voltage side. Okay. First of all, we consider the high voltage side. Okay. So we first of all, our objective is to choose the base value of the high voltage side and base impedance of the high voltage side. Okay. So how we can find base voltage and base MVA. Okay. From that data, we just find out the base impedance value. Okay. So base volt ampere rating is your same as the power rating of the transformer on both sides. That means LV side or HV side. Okay. Only differ the base voltage or voltage value from the high voltage and low voltage are different. Okay. That means the high voltage side you have to consider 2500 volt and low voltage side you will consider 250 volt. Is it not? So 2500 and 250 volt. And power rating are same as the high voltage side and low voltage side of transformer. So that will be nothing but equal to 20 kVA. Okay. So for if you consider high voltage side, that means base voltage on the high voltage side, we consider that whatever the rated voltage on the high voltage side of the transformer, that is nothing but 2500 volt. Okay, so this value we consider as the base voltage of high voltage side. That is represented by B suffix BH. That means this we represent for which one? Base, and this H is represent for high voltage side. Okay, so you have to familiar with the standard notation of this quantity, how we can represent either base voltage on the high voltage side, base current on the high voltage side. That means you have to write or mention in the suffix letter their base value along which side. Okay, so if we see here that the V suffix capital VH, that means base voltage on the high voltage side. IVH, that means base current on the high voltage side. Okay, so base current of the high voltage side is how you can find out this base current. That means we already given in the problem that power rating. Okay, we already choose their rated voltage on the high voltage side, that is 200 500 volt. Okay, so just divide this voltage in which quantity. That means just to use the standard formula of current equal to power divided by voltage. Okay, so that base current equal to 20, that will be, if you convert in volt ampere, so just we multiply by 1000 for convert this quantity in volt ampere. Okay, so 20 into 1000 is nothing but 20,000. Okay, divided by voltage, that means along the high voltage side, that we consider here 2500 volt. हेलो, हाँ सर थोड़ा देर में भेज दें 10 मिनट। हाँ हाँ 10 मिनट में भेज देना सर, 10-15 मिनट टाइम दिए। Okay, so you just maybe find out here the value of base current on the high voltage side. That means power divided 20,000 divided by 2,500, that is nothing but 8 ampere. Okay, 8 ampere. Now you can find out the base impedance on the high voltage side. You already find the current here on the high voltage side, and you already choose here the base voltage. Okay, so ZPH equal to VBH by IBH, that is nothing but 2,500 divided by 8. Okay, so ZPH equal to VBH by IBH. So just if you write here, then you will get the value of ZBH equal to VBH by IBH equal to 2,500, that is voltage, we already mentioned here. So 2,500 volt divided by 8 equal to 312.5. Okay, 312.5, that is base impedance on the high voltage side. Okay. So now you can convert this impedance value in per unit, because you already find here the base impedance on the high voltage side. So part A you can now find here. That means equivalent impedance on the high voltage side equal to equivalent impedance in ohm divided by base value of the high voltage side. Okay, so already you base impedance find here. So just this one you can convert for part A on this two data. So ZEH in per unit equal to ZEH in ohm divided by ZBH in ohm. ZEH in ohm divided by ZBH in ohm. So 2.6 plus J4.3 divided by base value of the impedance on the high voltage side, that means 312.5. If you solve this equation, you will get 0.0832 plus j 0.01376. Okay, so this is your per unit value of equivalent impedance on the high voltage side. Now, how we can solve for the part B, that means low voltage side. Okay, how we can solve for the part B. Okay. So for part B, we just consider here, that means ZEL. Already know that how we can impedance transfer from low voltage side to high voltage side. Okay, so here the impedance given on the high voltage side. Okay, so we require to transfer this impedance on the low voltage side. Okay, so how we can transfer along the low voltage side? How we can transfer along the low voltage side? So if you remember that, how we can transfer impedance from one side to another side, that means जिस साइड हम लोग को ले करके जाना है इम्पीडेंस, ओके, उसके टर्न्स रेशियो होल स्क्वायर का टर्न्स रेशियो से मल्टीप्लाई करना है. दैट मींस यदि हाई वोल्टेज को हम लोग को लेके जाना किधर, लो वोल्टेज साइड, दैट मींस हम लोग को मल्टीप्लाई करना पड़ेगा यहाँ पे ZEL इक्वल टू ZEH इंटू NL बाय NH. हम लोग लेके जाना है किधर, लो वोल्टेज साइड. तो जो लो वोल्टेज साइड लेके जाना है उसका टर्न्स नंबर ऑफ टर्न्स ऊपर रहेगा, और जिस क्वांटिटी को लेके जाना है हाई वोल्टेज साइड की क्वांटिटी को लेके जाना है वो नीचे रहेगा. यदि हम लोग चाह रहे हैं कि लो वोल्टेज क्वांटिटी को हाई वोल्टेज साइड में लेके जाना है, दैट मींस ZEH इक्वल टू क्या हो जाएगा, ZEL इनटू इस साइड लेकर के जा रहा है, दैट मींस number of turns of the high voltage side divided by number of turns on the low voltage side. Not number of turns of the high voltage side divided by number of turns on the low voltage side whole square. Okay, but here we require to convert the high voltage side parameters to transfer to low voltage side. That means ZEL equal to equivalent to ZEH turns ratio of turns, that means number of turns of the low voltage side divided by number of turns on the high voltage side whole square. Okay, so if you multiply by this number of turns of the low voltage by number of turns of the high voltage side whole square in ZDH, then you will get the equivalent value along the low voltage side. Okay, so just we put here on this formula here, that means ZDL equal to 2.6 plus J 4.3. Okay, 2.6 plus J 4.3. That means 250 divided by 2500 whole square. Okay. 250 divided by 2005 square. So this one will becomes how much? 1 by 10. So 1 by 10 whole square. That means 1 by 100 is not. So 1 by 100. So 1 by 100. Okay. So just you multiply this one or simplify this equation, that means ZDL equal to 2.6 plus J 4.3 into 1 by 100. Okay, that means 2.6 divided by 1 by 100, that means you will get how much? This one 0.026, is not 0.026. So this one first term is 0.026 and this one is J 0.043, is not J 0.043, J 0.043. Now you find the impedance on the low voltage side from high voltage side. Okay, actually in problem impedance given along the low high voltage side, but you required here to transfer that impedance on the low voltage side. So that will be equal to nothing but 0.026 plus J 0.043. You know, 0.026 plus J 0.043. So Now we require to find the low voltage side base impedance. So that we first of all just consider here the base voltage on the low voltage side. So base voltage on the low voltage side is the nothing but rated voltage of the low voltage side of the transformer. Okay, that is given in problem 250 volt. 250 volt. So VBL equal to 250 volt. Now you just find out the base current on the low voltage side. So what is the value of base current? Same formula we use here. That means power is same on the low voltage side and high voltage side. That is 20,000. So 20,000 divided by base voltage on the low voltage side. So if you divide this power, that means 20,000 divided by 250, then you will get almost equal to 80 ampere. Okay, so 20,000 divided by 250 equal to 80 ampere. Now you already find the base current on the low voltage side, and you already choose the base voltage on the low voltage side equal to 250 volt. Is not 250 volt. So that ZBL equal to, if you want to find out the base impedance on the low voltage side, so that is equal to base voltage on the low voltage side divided by base current on the low voltage side, that is equal to 250 divided by 80. Okay, we already find here that means current. Where is the IBL? That means this one 80 ampere. Okay, so ZPL, that means base impedance on the low voltage side, is equal to 250 divided by 80 equal to 3.215. So this one is your base current on the low voltage side, 3.125. Okay, 3.125. So this is base current on the low voltage side. Now base impedance on the low voltage side. Now we can find the equivalent impedance on the low voltage side in per unit, because we already find in actual value in ohm, and we already find the base impedance on the low voltage side. Now we are able to find the value. So now we can solve for the part 2. That means ZEL in per unit. So that is just we can find here, so that ZEL in per unit equal to ZDL in ohm divided by ZBL in ohm base value. So equal to ZEL in ohm divided by ZBL in ohm. So Z the base impedance of the low voltage side, that is represented by ZBL in ohm, that means it's in the same unit. Just put here the value of JDL in ohm divided by ZBL in ohm. So that is equal to how much? 0.02 plus J 0.043. That means just put here the value of leakage impedance of the low voltage side, whatever you obtained here, and base impedance of the low voltage side, that is equal to 3.125. So just put here 0.026 plus J 0.043 divided by base value, that is equal to 3.125. Okay. So now you just simplify this equation. So this one divided by this one and this one divided by this one, you can write here. So just write 0.026 divided by 3.126 25 plus J 0.043 divided by 3.125. So J 0.043 divided by 3.125. Now you can simplify this equation, so you will be able to get the value of equivalent leakage impedance on the low voltage side in per unit. Okay, so this one now we can represent this, just simplify this equation. So that is equal to ZEL, that means equivalent leakage impedance and leakage impedance in per unit equal to, just divide this one 0.026 divided by 25. So just use this one 0.026 divided by 3.125. So 0.00832. If you solve this equation, you will get almost equal to 0.00832 plus J, this one just divide by 3.125, so we will get almost equal to 0.043 divided by 3.125. So this one is equal to almost 0.00832. 0.01376. Yeah. So you will get the value of equivalent leakage impedance on the low voltage side is equal to 0.0832 plus J 0.0136. Okay, so you can practice some problem based on the per unit quantity. Okay, so first to try to see how we can approach for solve any numerical related to per unit quantity. We just to consider here a transformer. Similarly, you may consider more electrical component consist in a power system, that means transmission line and alternator or load. Okay, and maybe also consist of transformer. Okay, so we consider here next problem, that means problem over here 5. That means a 35 kVA transformer has the following parameters. Meters, that is represented by and voltage rating given here, that means 11,000 by 440 volt. So resistance on the high voltage side, that is equal to represented by R1. So, on the high voltage side, R1 equal to 15 ohm, X1 equal to 25 ohm, and R2 equal to 8 ohm, and X2 equal to 12 ohm. Okay. Find the equivalent attachment. Equivalent resistance in per unit equivalent resistance and reactance equivalent reactance in per unit on HV and LV side. Okay. So maybe try to solve this problem. Just first of all find the equivalent resistance and reactance along the HV and LV side, and then convert into per unit quantity. Okay. So first of all, if you consider here in suffix 1 and 2, subscript 1 and 2 as the HV side and LV side. Okay. So if you consider, that means HV side, okay, HV side, then what is the total equivalent resistance on HP side, HP side, that is equal to how represented by RE1, RE1 means RE1 equivalent resistance on the high voltage side, okay, equal to summation of the high voltage side resistance plus transfer resistance from the low voltage side to high voltage side, okay, that is represented by R1 dash, or maybe directly just put here R1, that means this one here, R1 plus R2 into high voltage side number of turns divided by low voltage side, because we convert resistance from low voltage to high voltage side, okay. So that is represented by NH or N1 divided by N2 whole square, okay, whole square. So just put here the value R1 given to you 15 ohm, so just 15 plus R2 given as 8, so just put here 8 into N1 by N2 whole square. So N1 is your how much? 11,000 divided by 440 to the power square. So solve this one. 15 plus 8 into 11,000 divided by 440. So this one becomes as 11,000 divided by 440 equal to 25. So 25 whole square is equal to how much? 625. So we'll be right here. 25 whole square equal to 15 plus 8 into 625. That means equal to so 8 into 625 is 5,000. So 15 plus 5,000 equal to 515. Okay. Similarly, you may find out here XE1, that means equivalent leakage reactance on the high voltage side. So XE1 equal to X1 plus X2 into N1 by N2 whole square into N1 by N2 whole square. 1 by N2 whole square. So just now put here the value of X1 and X2. So X1 equal to 25 plus X2 equal to 12 into same value, this one, so 25 whole square, maybe right here, and 25 whole square. So you maybe solve this equation and just write here 25 plus 12 into 625. Okay. So you already converted high voltage side. Now just simply find out the base impedance on the high voltage side and just divide this quantity 550 15 and this one by base impedance of the high voltage side. Then you will get the this quantity in per unit. Okay. So you may practice a lot of problem based on this one. Okay.